Hi students, good morning. Last day we were discussing about the intermolecular forces, different type of intermolecular forces and the difference between intermolecular and intramolecular forces. Now today we are going to discuss about the thermal energy. So let us start discussion about the thermal energy. So this is the energy gained by the particle due to movement of the particle. Okay, the thermal energy refers to the energy of a body that arises from the motion of its atom or molecules. So whenever they move, it will arises a thermal sort of energy called thermal energy inside the body. Okay, so the thermal energy of a substance is directly proportional to the temperature of the substance. So the thermal energy that is directly proportional to the temperature of the substance. Okay, so as the movement increases, the thermal energy also increases and the temperature also increases. Okay, so now let us discuss about the intermolecular forces versus thermal interactions. Okay, so intermolecular forces keep the molecule together, right? So we know that we have three different states we were discussing about, right? So what are the three different states? Solid, liquid, and gas. Okay, so in solid state, particles are very closely packed. Liquid state, they are little far apart, and in gas they are far apart, right? So that is what we know. So if the intermolecular forces are very strong, that will be existing as solid because there is a strong intermolecular force of attraction and the particle will come close together and that will be solid. Okay, so it's weak, it will be liquid, and if it is very weak, that will be existing in the gaseous state. So nearly if the intermolecular forces break, that will be is converting into the gaseous state. That is what happens. So intermolecular forces are those which help the particle to come close together. Okay, so what about, so if predominance of intermolecular interaction, so if the intermolecular interaction increases, gas become liquid, liquid becomes solid. So in the solid state, the intermolecular interaction is maximum. Okay, so predominance of thermal energy. So if we are discussing about the thermal energy, the same thing, solid, liquid, and a gas. So the solid, liquid, and gas, if the intermolecular attraction is more, it is solid, then it is liquid, then if it is least, it is gas. Okay. So if you increase the temperature of the solid, what is going to happen? It will be converting into the liquid state. Still, if you are increasing the temperature, it will be converting into the gaseous state. So thermal energy, if increases, what will happen? The opposite way it will move, means the solid will be converting into liquid, liquid will be converting into gas. Understand? Yes. Now, okay. Next, we are going to discuss about Boyle's law. So what do you mean by Boyle's law? Boyle's law was stated by a scientist, his name is Robert Boyle. Okay. So what he stated, according to him, what he stated was that at constant temperature, very important, this law states that at constant temperature being constant, the pressure of a fixed number of moles of a gas, the pressure of a fixed number of moles of a gas varies inversely with its volume. Mathematically, how can we explain it? Pressure is inversely proportional to 1 by V at constant temperature. Understand? So, or if you are taking a vessel, suppose you are taking a vessel, it is full of a gas, a particular gas inside that. So, when you are applying a pressure into that, what will happen? If you are applying a pressure into that, what will happen? The piston will move inside, right? So, before the volume was this much, and if you are applying a pressure, what will happen? The piston will move downwards and the volume will decrease here, right? So pressure, if you increase the pressure, what is happening to the volume? Volume is decreasing. So pressure and volume is inversely related at constant temperature. That is what was stated. That was our Boyles law. Okay, so this one we can write it as P is equal to K1 into 1 by V. So this is a proportionality constant. We removed this proportionality. So this is putting as a proportionality constant. Or you can tell PV is equal to a constant. PV is equal to a constant. So you can write two instances, right? P1, V1 is equal to a constant, or you can write P2, V2 is equal to a constant, or you can write P1, V1 is equal to P2, V2. Understand? P1, V1 is equal to P2, V2, or you can write it in this term also, P1 by P2 is equal to V2 by V1. So this is used for what? This is used for calculation. All the three quantities, any three quantities will be given, and if you want to find out one quantity, we can use this equation to find out that. Understand? So Boyle's law, what Boyle's law was stating? Boyle's law stated that at constant temperature, the pressure of a fixed number of moles of a gas that varies inversely with its volume. So P is P1 V1, P1 V1 is equal to P2 V2, which is equal to a constant. Okay. Now let us move to the next slide. If you take the next slide, you can see one thing here. Okay, we are plotting pressure against volume, right? We are going to plot the pressure in bar against volume. So when you are plotting pressure against volume at a constant temperature, the curve you are obtaining is called isotherm, because this curve represents the variation of pressure against volume at constant temperature. So curve at constant temperature, that is what we are called isotherm. So these are called isotherm. This is corresponding to different constant temperatures. So this is 600 temperature. So this is one isotherm. This is second isotherm. This is third isotherm, because they have constant temperature. Curve drawn at a constant temperature, that is called isotherm. Okay, so you can see that here from this graph itself, you can understand if the pressure is at the peak point. Look at this. This is the peak point of the pressure here. So if the pressure is at the peak point, what will happen to the volume? Corresponding volumes, you see, that will be very less. Okay, so that is what this particular isotherm is giving us. If you increase the pressure, the volume will decrease. That we will understand from this isotherm, and you can see that the isotherm higher curve corresponding to higher temperature. As the temperature increases, here the pressure remains constant here, and the volume will be different. That we will know in another law, that if the temperature increases, volume will expand. The gas will expand and the volume will increase usually. So that is the reason why if you increase the temperature, okay, even though it is a constant, at a different temperature, you will get different volume. What is the reason for that? Because the pressure is directly proportional to volume. That is coming in another law. We will discuss that. Okay, so suppose there is a calculation question that if a ammonia gas, okay, ammonia gas is enclosed in a cylinder, and its volume right now is 50 cm cube, and you apply a pressure of 1 atmosphere, and after that the volume will decrease to 50 to what temperature? 50 to 20 cm cube. Find out the pressure at that point. Okay, the pressure at that volume. So how we will calculate this? Okay, ammonia gas enclosed in a cylinder. Its volume right now V1, we can write it as V1, that is equal to 50 cm cube. Okay, and 1 atmosphere, its volume is 50 cm cube at 1 atmosphere. So P1 is equal to 1 atmospheric pressure. Okay, now what is next? V2. V2 is equal to what? 20 cm cube. So what will be the pressure? Pressure we have to find out. So how we will find out it? P1 by P2 is equal to V2 by V1. The same equation we are using. Substitute 1 by P2. We don't know. X is equal to V2. What is V2? 20. And what is V1? 50. 20 divided by 50. Or you can write X is equal to 50 by 20. Understand? Or 5 by 2, that is equal to 2.5 atmospheric pressure. Clear? So in this way, if you know one value, you can calculate the other value, pressure or a volume, using this equation, that is P1 V1 is equal to P2 E2. Okay, so P1 V1 is equal to P2 V2 is equal to a constant. And one more thing you have to remember here is, suppose we know that if you are increasing the pressure, what will happen? The volume will decrease. So the final volume I can see, if it is very near here, what will happen? The particle will come close together and it will be very close together. So what will happen to the density at the end? So the density will increase. Okay, the density of the gases will increase. What's the reason? What is density? Density is equal to mass by volume, right? The density is equal to mass by volume. So here what will happen? Per volume, if you are looking at per volume, the number of particles present will be very less, so that the mass by volume will be very less for a unit volume. But here you see, if you are taking a same volume, what will happen? The number of particles present will be more, so mass will be more, so the density will also increase. So that is another thing. And we have already discussed here about the thermal energy part. Okay, that's also important. Here we will get an idea of how to liquefy a gas, how we can liquefy a gas. So how we can liquefy a gas? Liquefying a gas. So in order to liquefy a gas, two things you can do continuously. So in order to liquefy air, it is difficult. So you are doing two processes together. Okay, you know from this that if the thermal energy increases, it will be converting into gas. So if the thermal energy decreases, it will be converting into solid or liquid, right? So the thermal energy decreases means you have to cool it. When you cool it, the molecular motion also decreases. Molecular motion decreases. And so what will happen? It will convert into liquid. So one thing you can do is you can cool it so that it will liquefy. And another thing you can do, what you can do, you can increase the pressure of the gas. Increase the pressure of the gas. So two things we are doing. Cooling it means you can decrease the temperature. You can decrease the temperature and you can increase the pressure. These are the two things you can do to liquefy a gas. Okay, because if you increase the pressure, what will happen? The particles which are far away will come close together. So the intermolecular interactions will increases when the particle come close together, so that it will have a tendency to move into the liquid state. That's all for today. Thank you.